Example 1.34. The variation of resistance R ohms of an aluminium conductor with temperature theta degree of Celsius is given by this differential equation. So we always start by the differential equation. So we want to solve this. Okay. And then what is alpha? Alpha is the temperature coefficient of resistance of aluminium. Okay, let's start by solving this differential equation. So this is first order. The technique that we want to apply is separation of variable, because we can bring R to one side, right, and theta to another side. So let's makes 1 over R dr, and on the right we have alpha d theta. Alpha is just a constant. Then put the integration on both sides. So the integral of 1 over R is ln R. Alpha is a constant. The integration of a constant with respect to theta is alpha theta plus C. Then we want to find R. Since R is stated in ln by using the logarithmic properties, you can write R is E, or exponent of alpha theta plus C. This can also be written by this. I can write A E alpha theta, where here I set A equal to exponent of C. So your current solution now is this. Okay. Next, we want to solve question 1. Okay. If R equal to R naught when theta equal to 0, solve for the equation for R. So problem 1, if R equal to R0 or R naught when theta equal to 0 degree of Celsius. So let's substitute this into the current formula here. So R is R naught. A is still unknown, E, and theta is 0. So we have this, E power of 0 is 1. So here we obtain A, where A is R naught. So you can update your solution. R equal to A becomes R naught, E alpha theta. So this is the answer for question 1. Question 2. If alpha is given 38 times 10 to the power of minus 4, determine the resistance of an aluminum conductor. What is resistance here? Resistance is denoted by R, so you have to find R. At 50 degrees Celsius, what is the temperature? The temperature is denoted by theta, so this value is for theta, right? When its resistance at 0 is 24 ohms. Okay, so here you have a condition when at 0 degree the resistance is 24 ohms. So we want to apply those info. At theta equal to 0 degree of Celsius, it is stated that R is 24. So what can we obtain from here? Let's substitute into the original to the current formula. R R is 24, R naught is unknown, E and theta is 0. So here E power of 0 is 1. So now we know that R naught is just 24. So your current solution becomes 24 E alpha theta. So you can update the formula. Yeah. Okay, back to question 2. If alpha is given as 38 times 10 minus power of minus 4, determine the resistance. Okay, what is the resistance when theta equal 50 degree of Celsius? So we can just insert into the current solution, the current formula. R is 24 E, alpha is given 38 times 10 to the power of minus 4, and theta is also given as 50, right? So you can calculate this, you will get 29.02 ohm. So that is the answer for question 2.